Good afternoon, everyone. Good evening, everyone. Today we are here to learn about cloud computing. So firstly, I am Mayank Aroda, and Microsoft Azure Developer Community, in collaboration with AR Club Community, presents you College to Azure Cloud Journey session. Today we have here Dibyasam Puhan sir, who is a full stack developer at One Solution. Today he will be teaching you about all the basics of cloud, how to start with Microsoft Azure, and what is the benefit of and application of Microsoft Azure fundamentals. Over to you, Divyasam sir.
Thank you, and thanks for the introduction, and welcome to the session for my introduction to Microsoft Azure fundamentals. So, in this session, let's make sure that we are all on the same page with the key goals of the session. The first and the most important thing is we need to know what is cloud computing, right? Like, why do you need cloud computing? Then we'll see how Microsoft Azure fundamentals comes into this picture as one of the leading cloud providers. And then hopefully by the end of all these sessions, by the end of this session you might draw some inspiration how you can use, or how your future projects can use Microsoft Azure to you know to scale your products, to actually move your personal products from your system to a cloud, and then you can actually display them, showcase them in a better way, make it available for the entire world to use, rather than just them showing them as a project, right? So let's get started. So first of all, we're going to start with what is cloud computing, right? So to understand what is cloud computing, we must let's understand with an example. So imagine you have an application that works fine on your system. It runs fine, it does everything that it is supposed to, and it does the job. But what happens when you want to show this application to the entire world? What happens when you want to make sure that you are not the only user of the application, but everyone on the internet should be able to use it? So how do you do that? One single system, your system cannot handle that kind of load, right? So many actual real world traffic which can go up to gigabytes of data flow per second. A normal single system cannot handle that. Secondly, what happens if your system fails? Let's say somehow you set up a server, your application is running on your system, it's connected to the internet, and other people are using the application from your system. So what happens if the power fails? In case of a power failure, entire system is going to go down, it's not going to be available. What happens if your machine just restarts itself due to an enormous amount of load? What happens if you lose the data? What happens if the storage disk crashes? What happens if some virus goes in? Not only your system is going to go down, but you are going to lose all the data of all users who are actually present on your system. So how do you make sure that this data is always present, your system is all, your application is 24/7 online? All these things, these things come inside the come on the physical part of the server, right? We cannot control that manually. And secondly, what happens, let's say today your application is working fine, you have a number of users, and the other day your business grows exponentially. Let's say you do some kind of advertisement on Instagram or any social media platform, and you get a million of new millions of customers. So you see there is a direct shift from 0 to 1 million, from a scale of 10 to 1 million. So how does your application scale? All those things can be sorted when you go to a cloud computing provider. How is scaling handled? Well, in scaling there are a number of problems that you need to solve. For example, what happens if you run out of storage, because now there are many people using, not just 10. So you might run out of RAM, you will run out of storage disk, you will run out of computing power. Your server will just stop at first place. So, and at the same time, do you think it is actually feasible for you to update your system? Let's say you're going to run out of storage, so you go buy some disks and attach to your system. That's going to be a problem, right? To what point can we do this? So in such scenarios, we shift to cloud computing. Cloud computing allows you to rent a system, pay only for the amount of time that you're using the system, and it's a virtualization system. There you don't need to restrict yourself to a particular system. You can expand your system according to your needs. You can scale the number of systems that you are actually using. So one of the key concepts in cloud computing is called an Azure virtual machine. So we'll look into details what is an Azure virtual machine. We'll create that today hands-on. We'll deploy an application into it. But first, let's understand what is a virtual machine. So a virtual machine is basically an on-demand, scalable computer resource. Let's understand these three terms. What is on-demand and what is scalable? On demand means here your app, you are using your system as a physical entity. Similarly, a cloud machine is also a physical entity in a remote place. Typically you can configure where your application is going to be, deployed. For example, in virtual machines there are a number of locations that you can choose. United States, there are different regions inside United States. There are different regions in India, there are different regions in Europe. You can choose anywhere. So once you choose a location, uh, those your machine will be allocated in there. And on demand basically means you can expand on demand. For example, let's say there are 10 people using your system and new people join your application, so you can instantly allocate a new system and shift your and redirect your users to the new system. You don't have to worry about how these users are redirected or how they come and how they use. All you have to worry about your application. All these things on demand, scaling the application, making the computer resource available, making sure that you never run out of memory, making sure that power never fails, all this is going to be handled by the cloud provider, in our case Microsoft Azure. So you don't have to worry about these things. All you need to worry about is your business logic, that is your application. So that is where cloud computing is going to help you. On demand, scalable. Now when we come to scaling is of two types: horizontal scaling and vertical scaling. So if we talk about horizontal scaling, it basically means, let's say, you, you are at a point where your single system is not able to handle the traffic that is coming in. So you allocate a new system, and now both the systems together handle the total load. So the load is distributed. This kind of scaling of actually increasing the number of systems, is called horizontal scaling. And then there is something called vertical scaling, which means that you basically give your current computer more computing power. Let's say it has 4 cores and 8 gigs of RAM. You make it 8 cores processor and 16 gigs of RAM. So there are different kinds of scaling that is available. And on Azure, you have the complete flexibility to allocate whatever kind of system in whichever place you want. That is why it's called on demand and scalable. Now, virtual machines are generally used to host applications. We are going to do that today with a demo application that I'll share with you in a short while. And the customer requires more control over the computing environment than what is offered by other computing resources. So, other computing resources in Azure include, for example, if I go to Microsoft Azure, let me show you something. What are the different services that Microsoft Azure offers you? So let's go to Microsoft Azure services. Let's log in. So yeah, Azure is free for students. If you log in with your GitHub ID, you are going to get $200 worth of free credits, and it's all under your student subscription plan, and you can renew that every year. So it's free to use once you sign in with your GitHub, and make sure that you have enabled GitHub Student Developer Pack. So that way you get free access to Microsoft Azure, and while you are a student, you can renew it every year. All right, so I'm going to go into my Microsoft Azure portal. Inside the dashboard, let's see what are the different kind of resources that we get. So let's go to virtual machine is what we are using right now. Let's go to home or resources. More services, all services. Let's go to compute. So these are the different kind of computing solutions that Microsoft Azure offers you. Virtual machine is what we'll study today. Apart from that, you get Kubernetes, you get container instances. Then there is called something called app services. So what is app service here? It is even more managed. For example, when we use the virtual machine, we have to manage we are basically given an entire device with our configuration of choice, like a particular a particular processor, a particular kind of RAM, a fixed amount of storage, and things like that. and we have to manage everything, starting from installation of dependencies, installation of packages, configuring networks, configuring load balancer, everything we manage everything there. And this is what is called IaaS, infrastructure as a service. Now, when we use Microsoft App Service instead of virtual machine, here we don't have to worry about these low level details. All we need to do is provide our code. We just give our code and we just give a list of application libraries or dependencies that we are using, and your app service by Microsoft Azure is going to manage everything. Here you don't even need to worry about the availability of packages, load balancing, your installation of dependencies, nothing. You just give your code and it will do everything. So but what is the problem? If everything is being handled, then what's the problem here? The problem is you lose control over the low level functionalities which a virtual machine can give you. Here you only have control over your code. You just give the code, and rest of the infrastructure part will be handled by Microsoft Azure. But if you think that you need some low level details, you need some extra functionalities, then virtual machine is your way to go. If you think you have small application that can be contained within an app service, for example, let's say you have you're making something similar to YouTube, and you want to make sure that every time someone uploads a video, you show a thumbnail that like the first frame. So you're not going to create an entire virtual machine for that job, right? You don't want to spend so much money, make an entire virtual machine that handles these basic functionality of creating a thumbnail for a video. You can create an app service. All you need to do is few lines of Python code, and you run that in your app service. It will be managed, it will be automatically scaled. You don't need to worry about dependencies, nothing. Application service will handle that for you. Then there is something called containers. Like if someone here in the audience is well versed with Docker or containerizations, this is something a place where you can run your container instances. For those who don't know what is Docker, well, container allows you to not only ship your application, but along with the application you can also share its development environment. Like you ship the entire environment instead of just the code. And it's one of the best application modernization ways. And then there is Kubernetes, where you control these containers. But let's not dive into all these details. There are n number of compute resources available. Let's focus on the goal of today's session, that is a virtual machine. So yeah, that's what it says. Virtual machines are generally used to host applications when the customer requires more control, and that's what we discussed, how virtual machine is giving you more control compared to all the other services. Now, when you leverage a virtual machine to host an application, you get the flexibility of virtualization without the need to buy or maintain any underlying physical hardware. Like we discussed, if you run your application on your own system, let's say you're running out of storage, let's say you're running out of networking capabilities, let's say you're running out of compute power, you will actually have to update your system, right? Let's say you're running an application on your system and you feel that your processor, let's say it is i3, is not able to completely efficiently power your application the way it should be working. So what you do is you go to the shop and you buy a latest i9 processor, very expensive and very capable. So everything is working fine. But now there are 10 more people join your application. Your application is now being used more widely, so your i9 is going to fade away, right? It cannot handle that kind of load. So will you buy another i9? Will you buy another system? Right, that is where you're going to just investing money, and then not just investing in buying products, you have to maintain it, you have to update it time with time. So a virtual machine gets you rid of that problem. You don't need to worry about that. Basically, there is a term in cloud computing called virtualization, where you are allocated a virtual amount of CPU, a virtual amount of storage within a particular device, and all that. And that is how you don't need to worry about buying new things or worry about the physical hardware. Your cloud computing provider will manage that for you, right? Are there any doubts about virtual machines up till now, or we are going to start with the project and create a new system? Yeah, someone says Kubernetes and Docker, right? You are on the right track for application modernization, that I can assure you. And Yeah. Are there any doubts, or we can move to the next part, that is creating a virtual machine and deploying an application onto virtual machine? Alrighty. Cool. So here we are back on Microsoft Azure portal. So from here, let's go to virtual machine. I'm going to delete some of the previous instances. Let's start anew. All right. So, all right, let's start with the project, right? So before I jump into the project, let me share the project with you, and let's first see how the project actually works. Let's first test the project on our local system, and then we'll move on and see how we can make this project available to the entire internet by deploying that on Microsoft Azure. So I'm going to open my VS Code. Now you don't need to worry about the code that is present here, because this session is not about writing backend or server side code, right? This application is about deploying application. This session is about deploying applications to the server or to the cloud. So typically, the role of a cloud engineer does not include writing backend codes. So don't worry about the code. All we need to do is make sure that this code runs on the runs on our system, and then we will make it run on Microsoft Azure virtual machine. So that's all we need to worry about. So as a cloud engineer, what are our key responsibilities? Like, how do we know how to make the application run, and things like that. So basically, when we need to make an application run, we should know what are the dependencies or libraries it require. We'll set up that environment for it to run, and that's it. And then we are going to deploy the application. So inside the application, there is a file called package.json. This includes names of all the dependencies or libraries that this application is using: nodemon, multer, morgan, helmet, express, ejs, crypto, etc., etc. So that's all we need to worry about. We just need to make sure that these applications are installed on our Microsoft Azure VM. And if all these things are present, we don't need to worry about anything else. Our application will be running. So let's first locally run the application, and then we'll move on to cloud. So let me open my terminal. Can have a few things open. All right, so I'll move on to the project directory, Azure Workshop. Cool. So let me also share the application with you guys. I believe I can copy from here. Please share this application with the YouTube chat, right? I think it will be available to all of you. And now let's move forward to the application. So I hope all of you know how to use Git to clone the project. The command is go to your you can either open the link directly in GitHub and download the code from there, right? This is how you download the code from GitHub. Let me show that also. uh, when you open the link, this is where you will be. There is a code button right here. Just click on download zip. If you're not already, if you do not have Git installed in your system already, if you have Git installed, then you can use this http command. Just copy this, and all you have to do is in your terminal, if you are on Linux, then terminal. On Linux and Mac, it is the terminal. On Windows, your CMD. Just write this command git clone, and paste the link. So yep. Okay. Once you paste the link, this will download and create this Azure Workshop folder in your wherever you are running the command. So once we have the repository on our system, we can test it out, and then we deploy it. So first, let me show you what the project does, and then we'll deploy it onto Microsoft VM, right? So Well, I told you, right? To run an application, we need to make sure that these packages are present. So for that, we normally, since this is a Node.js project, it uses Node.js and MongoDB. So for Node.js, there is just one basic command, npm ci. Npm ci, if you are running it inside the project folder, see, I am inside the project folder. If I write ls, you can see that I am inside this particular folder, right? These are the same files that are present here. So if you are inside your project folder and you just write npm ci, this will go ahead and download all the dependencies that are mentioned in the package.json file. So this is one single command that you need to run. You don't, if you have node.js installed on your system, then run this command. Else we are just directly going to deploy it on vm, and then we'll test it from there, right? Here I'm just running the npm ci to show you how the project works. So to start the project, all you have to do is write npm start. It will take a second, and then it will show listening on port 8080. So now let's copy this link, and I'll go to the Google Chrome and paste this link. So if I now open into register, you can see that I am at a particular URL. The URL is IP address 127.0.0.1. 127.0.0.1 is a special IP address, also known as loopback address. You must have learned about it in your networking course in your academics. Basically, what this address, if you have not, basically what this address means is on whichever system you are running on, 127.0.0.1 will always loop back to the same address. It is a self address. In place of this, you can also write localhost. It will mean the same thing. If I write localhost and type enter, uh, basically nothing changes. Basically, your system is known as localhost or 127.0.0.1. Now, inside that, in our system, in port 8080, our server is working or listening. So we have created inside our application, we have created an URL called register. So if you, once your server is running, if you come to this particular URL, this is what you will see. Do not worry if it's not running on your system right now, because it requires Node.js. We'll make sure that it runs on Microsoft VM. So what this does is basically you give this an email ID. This is a profiling application. It lets you create your profile online. I'm going to write my email ID, a fake password, and then I'll use some kind of profile picture. I'll create. Let me find a good profile picture. Yeah. I'll use an elephant. A purple elephant. Agree to the license. Sign up. Okay. So once you sign up, you will see a confirmation that user registration was successful. A green tick. Well, not green, but a tick. And then if you click on explore, you are going to see all the registered users. So you can see we just registered purple elephant, our email ID, and the photo is submitted. So that's all this application does, a simple form, and then it shows all the registered users. So now we just saw what that project does and how it works. Are there any questions about it? Okay, I can see none right now. So let's go to the next step. This is how the project works, and these are the kind of logs it will generate every time someone tries to access your project. So now what we'll do is instead, right now it runs on our system. Now we are going to make sure that it runs on the remote system. So to do that, we are going to deploy this into Microsoft Azure VM. So let's go to the Microsoft Azure portal. Now, by default, when you just sign in, this is where you will be in the default landing page. From here, if you are able to see virtual machine options directly, then good. Let's just click from here, virtual machines, or you can also go to here. Then you can say to all services, go to compute and virtual machine. So virtual machine is the most fundamental computing resource that is available to you inside the Microsoft Azure portal. So in here, I did stop the server, right? Okay, not a problem. So inside here, we are going to click on create. and we're going to create a virtual machine. So now I'll walk you through how to create a virtual machine, make it available, and access it from your local system. So let the subscription be at its default because I'm using a Azure for Student coupon or a validation. So you can sign up with your GitHub account to get this Azure for Students. Now a resource group is nothing but just a namespace. So that this allows you to group all your resources, like your virtual machine, your database, your xyz things that are basically working together for the same thing, like that is your project. So this resource group allows you to group all your resources under one name. So I've already created a group called Azure Workshop. If you want to create new, just click here, create new, and give it a name, and it will create that. It does not require any configuration, it's just a namespace. So now we'll name the virtual machine. Now in name, well, we can give anything. I'm going to say Node.js profiler. So this virtual machine, since this will be running a Node.js profiler application, let's just name it Node.js profiler. The easier and the more meaningful the name is, the better it will be to find it later. Security standard image, keep all these settings to their default. You can play with the region. Typically when we are creating a virtual machine for an actual enterprise or in an actual company, we want to make sure that the location that we are choosing is closest to the clients that will be using it. So right now we are doing it for learning purpose, so you're free to choose any location you want, won't be a problem. And next we are going to select image. Image allows you to remember we learned that virtual machines are basically on demand scalable system created out of virtualization, blah blah blah, all the all the theory things. So this is one of the configuration that you are free to choose. In here you can virtually select any of these images or operating systems. There is Windows, there is Windows Server, CentOS, an open source Linux, Debian, Oracle Linux, Ubuntu Server. So these are all the operating systems that you can choose any one of them, and Microsoft Azure will install this operating system or will choose one of the installed system. Basically you're going to get a virtual machine which will have these one of these operating system installed. So here let's go with Ubuntu Server 20, or you can choose 18. It's up to you, both of them will work fine for today's project. So Microsoft Ubuntu Server 20.04 LTS long term support, right? Let's go with that. Authentication type, make sure that you are on SSH public key. Now we are later going to use this SSH public key to access our virtual machine. Let's give it a name. Well, basically this name will be the default username, a user that will be created inside your Linux machine. So since we are using a Linux operating system, well, you must know, if all of any one of you have used Linux, you must know that it's inside Linux, the user and user rights are very important. Otherwise you cannot do a lot of things on your system. You cannot install packages, you cannot move files from here or there. So make sure that you are using a username, and you later on we access with that particular username. Then we have SSH public key source, make it generate a new key pair, and note this name later. We will be downloading this file later. For inbound ports, for now let's select everything that is available. We want to make sure that all the protocols are accepted, and we are going to do disks. So in here then you can again select what kind of disk you want to be attached to your system. Now this is another benefit or advantage of virtualization. Well, you can just choose, do you want a premium SSD, or you want a standard SSD, or you want just a hard disk attached to your system. So you can configure all these things. Thanks to virtualization, you can control what you get. Now you don't have to pay for buying this product. All that you will be charged for is for what time were you using these resources, only for the time that you are actually using these resources. So since we are on student quota, we are not actually paying. Let's just select premium SSD, or and since this application doesn't use read write operation, so we are actually not, we don't bother about storage here. Now there is encryption type. keep it at default, and we can go to networking. Inside networking, you can keep all the settings at its default. We'll play with them later. Just make sure RDP is enabled, remote desktop protocol, and keep all these settings at its default. Right now, let's not play with this. We'll change this configurations later, because there is something that we need to configure here. But we'll do that later once we notice the problem. Once we figure out what's wrong with this configuration, we'll change it. Then there is, well, basically you can keep all of these things at its default. There is diagnostics and data collection part. Advanced, nothing to change here. These are the preview. There is custom data. Custom data allows you to write up any shell script that will be executed every time your system is booting up. Now there are all these extra configurations. Now we are going to give it a tag. Purpose of the machine, or let's say Azure Workshop. Well, you're free to give basically any tag. This just helps you. This just makes it easier for you to find in a group of projects. You can skip it. It's not even required. Review and create. So once you come to the review and create, in the final page, it will take some time to validate all the data you have given. You get a green tick, so you're good to go, and we'll create the machine. Now here, select on the download key pair, because that is how we'll access our machine later. So this will download a .pem file on your system. Now this is what will allow you to access the system, to access the remote system, because your machine is secured. It cannot be accessed by anyone. So you need this configuration or secrets. This is basically a secret file, also known as a key, which will allow you to access the system. Technically, we just call it a key file. That's it. Now, let's go to all resources, and we can see that our Node.js app is spinning up, right? Let's go to virtual machine, all services, virtual machines. So our system is under deployment. It will show up here when it's done. Now, in the meanwhile, we have downloaded the PEM file. So let's go to downloads, and okay, there are lots of things here. What is the name of the file? Node.js profiler.pem. So we have Node.js profiler. Okay, so this is the name of the file. It is present in the downloads folder, right? So how will we access this? To do that, we can copy paste the command from here. Okay, so now our virtual machine is allocated. If you go into the system, you will see a connect button here. Click on connect and click on SSH. So if we go into SSH, run this example command below to connect your VM, you'll get a command. Copy the command from here, and we are going to paste it. So you can see that the syntax of the command is pretty simple. It uses the SSH protocol, SSH command line tool. It uses your username and the IP address of your system. So use the SSH to log in with the particular username that we have already created, remember, during the SSH keys VM configuration, and the IP address of the virtual machine wherever it is allocated. So this is the public IP address. You can check that here. If we go back to our system, Node.js profiler, the public IP address. This is the public IP address of our system, right? So we are just going to connect to that with our username and the IP address. Now, the only thing we need to change here is the private key file path. Now, well, if this was the only thing required, anyone can access the system without any security. So for the security, we need this particular file that we have downloaded. It must be downloaded in your system the moment you create the virtual machine. Okay, so let's give it the path of the file. Since I'm already inside downloads folder, I'm just going to do this and like that. So, okay, now I have already checked that this file is present. wherever you downloaded it, just open your terminal in that particular file, in that particular directory, and run this command ssh path through the file and your username and the IP address. I'm going to hit enter, type yes, and this will fail the first time. It might run on your system, but it will fail on certain Linux and Mac OS. The reason being, it considers that this file is unprotected. So this file is a very protected file, right? Because using a very private file, very confidential file, because using this secret key, anyone can access your system and basically access your enterprise data, servers, everything. So this needs to be protected at all costs. So to do that, we are first of all going to make this key read only so that it cannot be altered. Some systems directly accept this command. Some systems you have to make it read only to be able to use it. So what we're going to do is we will write chmod 600. Chmod is a command line tool, and if you type 600 inside it, um, it is basically, sorry, 600. V. All right. I've not copied the file name. Okay. So this is the syntax of the command. This is the syntax of the command. Chmod 600 is the value that we want to pass right now to make it read only, and the name of the file that we want to secure. Just run this command once. It will not give any output, but it will secure your a particular file. Now, if we run this command again, we are going to jump into the system. Okay. So now we are inside the system. We successfully booted in, right? Now there are no particular folders here. We are inside our Node.js profiler virtual machine. So this terminal now is directly whatever command we are running here is running inside the virtual machine. That's what SSH allows you to do. So now we are going to quickly set up our project inside the virtual machine. Now we have a virtual machine allocated. We have got its address. We are connected inside it. We are 90% there into deploying it. Now we have the final part of actually setting up the project. So what I'm going to do is I'm going to get the GitHub repository that I shared with you guys. So copy link, go back to your SSH into your system, just write git clone and the link of the repository. We're going to download the repository inside our virtual machine. So with this one step, we just got the source code of our entire application inside our virtual machine, right? So all our files are now present here. Are there any doubts at this point? I don't see any doubts at this point. So let's move on with the next step. That is installing Node.js inside it. So this is a virtual machine, a vanilla, clean, brand new virtual machine. This does not have a lot of things installed inside it except the essentials. But our application is a Node.js application, and it requires Node.js to be installed in order to run this server. So to do that, I've already mentioned these details in the README file. So if you open up the readme.md, you are going to get these two details, two commands. You just need these two commands to install Node.js. So if I assume most of you would be working on Windows. So in Windows, if you want to install anything, you just download the exe file or go to its website, download, and it installs for you, right? In Linux based systems like the one we are using right now, you can either do that, or the better in the more convenient ways, just a couple of copy paste a couple of commands and it's going to set up everything. So that's what we're going to do, because developers always do the lazy thing, right? So we are going to copy paste the first command, and this will install download certain packages from well, basically the Node.js repository, and we need these dependencies to install Node.js. So once this command finishes, we are going to copy the next command, that is install Node.js. This command is going to install Node.js on our system. All right. Now, for security, I have done one thing. Well, basically, this database. This project uses my MongoDB database to store data, but MongoDB database takes some credentials, so I have not written my credentials into the GitHub repository. To do that, what you can do is you need to create a .env file. A .env file is basically a file which includes all our environment variables. So we are not going to go to the system settings and add variables to the environment. If we just add those variables into the .env, the project can read it. So I'm going to write nano.env. It will open a text editor inside your terminal, and now here you can write commands. 1 second, give me a second. All right. So, I have just written the MongoDB connection string. For security, we normally don't never add these strings into the GitHub repository, and so I didn't. And inside this will basically tell Node.js where to store the data. Now, what we're going to do is we'll run that same command that we did on our system, if you remember some time ago, to install the repositories that it needed. Remember, we did npm ci. This installed all the dependencies that the project needs, or whatever is defined inside this package.json. It will install everything for us. So now, since this is a new system, again we have to do npm ci here again, because it does not have the dependencies installed, right? So once we're in npm ci, all the libraries that our project requires will be installed. After that, once this gives a green check, well, now you can also see there will be a new folder in a new folder present, node modules, which was not already there, when we did it previously. Ls, when I ran the ls command last time, you must have seen the node modules folder was not present, but now it's here. Node modules is basically a collection of all the files that we just installed with this npm ci command. So now all our files are present and we are good to go. So I will just say npm start. This will spin up the server. It shows which MongoDB it is connected to, and the server is running. So now, technically, we should be able to use our project. So we'll copy the IP address. See, now I cannot use the local host or the 127.0.0.1. I cannot use this address to access the project like I used to do. Remember, that's whenever our servers was running, we could use this URL to access our project. But now we cannot. 127.0.0.1, written it anywhere. Okay, just so now this site will not open up, because now the project is not running on our local server, but it's running on the virtual machine. And you, instead of 127.0.0.1, we have to give the public IP address, right? That is 20.124.176. It will be different for everyone, whatever your virtual machine says on the Azure portal. So inside here, we're going to open up register. But it seems that there is some issue with this web page now. It's still not working. So let's see what is the issue. Well, we already know that our server is running on port 8080. That's what you see on the screen, right? So as a cloud engineer, you need to make sure that whatever ports, whatever dependencies, whatever ports need to be exposed publicly should be exposed. Right now, we have not taken care of that. So if we go to uh, inside your application, let's go back to on the Azure portal, go to home and look for the resource group. So I'm going to open the resource group. Inside resource group, you will see all these resources that we have created. So there is the Node.js virtual machine that we have created, network interface, there is network security group, there is the virtual network, a disk, and the SSH. So all the not exactly your virtual machine, all the components of your virtual machine. So your Node.js application is using this network security group, right? Let's just make sure I'm on the right section. All resources. I'm going to do Node.js app profiler. Yep, this is what I've created. I was looking at the previous project. So there is this Node.js profiler network security group. This is what our application is using. We created Node.js profiler, the virtual machine right now, and there is an NSG attached to it. Every virtual machine, whenever you create it, has a NSG attached to it by default. And NSG is not a very not something very not some rocket science. It's a network security group. It just controls how and what requests can reach and exit the system. So what you're seeing here is well, basically all the kinds of networks that are allowed. So these are the protocols: SSH, HTTPS, HTTP, RDP, or the network names, and these are the protocols that are being followed, and these are the ports that are accepting requests: 22 443 80 3389. So we know that our application runs on port 8080, and although Node.js is monitoring that port from the inside, or our application is listening on that port from the inside, but that port is not receiving any requests from our browser. No one can access it because it is not publicly exposed, because that configuration is not defined in the security group. So to do that, we need to expose that group. So on the left hand side in this panel, you can see inbound security rules. Let's go into that. These are all the ports that are configured to accept requests. Here we are going to add source can be any source port ranges. um, let's make it 8080. Okay, this is source, my bad. This can be anything. Let's keep it at a asterisk. This will make sure that all kinds of resources are accepted. Destination is anything. Service is custom. We are going to use our custom application port, and our port is 8080. This is the port that we want to expose. So make sure that you type 8080 into this particular panel. Now let's give it a name. Let's say this is the Node.js port. All right. You can add a description if you want, and then we are going to add the security rule. All right, let's do the same with the outbound security rules. Let's go add port 8080, service is custom, everything is fine, and we're going to add this. So we added an inbound security rule and an outbound security rule, which accepts incoming requests at port 8080. All right, and also allows the server to send back requests. So now if we reload this page, well, the setting has still not applied. It takes some time, and this application is not running right now, right? In the background, we've not started our project. So here we're going to say npm start. And now, although this was working fine previously, it was still listening to port 8080, but now we've also exposed port 8080 publicly. So not only is this application now listening from the inside, but from the outside, the communications are now enabled. So now if we go and refresh the page, you can see that our page is finally loading up. And the images are missing here because I didn't add the images in the GitHub file. So those images are not present here, but we can, yeah, user application on the web page now. So there we go, guys. We created an application. Well, we created a virtual machine. We learned what is why we require cloud computing. Then we learned how Microsoft Azure is a cloud computing provider. Then we learned what is a virtual machine. We created a virtual machine. We deployed a virtual machine remotely. So now this application, which was earlier only working on my remote system, now it's also working on Microsoft Azure. And this link I can share with everyone. Or if you have a domain purchased, you can register this with your domain and use it with your own email ID or with your own URLs, like yourname.yourproject.com, something like that. So this is what allows you to showcase your projects for others to use. So now, not on, so next time you make a project, let's say any future project, do not just keep it to your system. Use Microsoft Azure to deploy it into cloud. and then you can share your projects, share your project into resume. You can add these links to your resume that this is where your project is live. Others can go and directly use it instead of just reading a description. They can use, and using, if your reviewer, if your um, client is actually using your project, it gives 10 times a better impression than just reading about the project on your resume. So, and not just your, I'm not just speaking from the context of your resume. Well, basically everything that, you know anything that benefits from it. Yeah, in hackathons, everywhere you are going to, a remote deployment is going to help you a lot. So, are there any questions at this point? Alrighty. So I think we have deployed our application. We learned how to use our application remotely. Hopefully, this session gave you some idea how your future projects can leverage from Microsoft Azure, how you can do better at hackathons, remotely make your projects available, and all those things. And this is just the beginning. You have 100 more resources available at Microsoft Azure, database, containers, everything. So I hope you would go and explore that now.
It was a wonderful session, sir. I
My
personally got to learn a lot. If you prefer, you can share your contact details with your LinkedIn profile with the users, the
Yeah, sure.
audience,
Do that.
so
Why
that,
not?
because when we implement things, we get a small errors to where we got stuck.
Yep, bugs are a part of a developer's life.
Yes, but personally, I got to learn. I hope it was a this session provided value to our audience, and I want everyone, the search profile will be shared in the comment box. You can also join the Microsoft Azure Developer Community Discord channel, where all the sessions link will be shared, all the quizzes happen where we can win Microsoft swags and all the things. You can get an interactive community where you can ask doubts too. Any doubts you can ask in the comment box, please.
Guys, this is the last announcement. Like, we have a Republic Day quiz on 26th of January at 8 p.m. on our Discord channel. So Discord channel link is highlighted in your screen. So please do join the Discord channel. We have the Azure quiz on 26th of January, and top 10 winners will be getting cool links. Bro, share the Discord link as well. Okay, I'm just resharing it again. So just join the Discord link, and top 10 winners will be getting the Microsoft, some cool tracks from Microsoft basically. So do join the Discord channel, and we usually just do some random quizzes there in like around 8 p.m. in Discord, Azure Developer Community Discord channel, where we give top three winners the Microsoft cool swags. So this is it. Anyone is having any doubt regarding anything, so they can ask in the chat comment box. We are open to queries now. And if not, we can just wrap up the session. We are the Vishom is our expertise done with the slides. So I guess no doubts right now. Perfect. So guys, do join the Discord channel. So that's it. Thanks for joining. Thanks for the Vishom taking this session. Thanks for hosting, Mayank.
My pleasure.
And thanks you. Thank you everyone. Have a nice day. See you
I
then.
hope this session was insightful. Take care, guys. All the best.
Yes. Bye.